Okay, this section, Chapter 1, Section 3, called Equations, is really a bridge in between what we've been doing in Sections 1 and 2 and moving towards solving equations. The stopgap for this is talking about domains, giving us sets, so basically things to plug in for x to see what's true. Essentially, what this problem is helping us do is, instead of solving this equation for x and having all of the numbers that exist be possibilities, they're narrowing down to 3 different numbers that we can try. Okay, so if you feel comfortable solving equations, maybe you've studied them before, or maybe you've figured out the algorithm on your own, then you're certainly welcome to do that. What I would like you to try to do, though, and especially if you haven't started solving equations or you just aren't comfortable with it yet, I want you to build a chart very similar to what they used in the book. And I'm going to, before I show you any work, I'm just going to talk you through what's going on here. I'm going to make it just a little bit bigger for us to work with. Okay, so let's talk about the notation that we have going on here. These brackets are designating a set, a group of things, okay? And it's called set notation. And what it's saying is that whatever variable we're talking about out here, the only options for that variable are whatever numbers or values show up inside the brackets, all right? And then instead of an expression, they give us an equation, and they're asking us, when we plug in the number 1 into this equation, is the whole thing true? In other words, does this side equal that side, right? And then we're going to ask that same question for plugging 2 in and plugging 3 in. The strategy that they give us is one that I really like, building a table here. So they take the set and rewrite each of the values in a row underneath the column that's marked x. Then they just transcribe the equation down into this column, and then they save this column for denoting whether the equation is then true or false. And let's just note that for ourselves also. So we've got true, false here. Okay, so now what do? They are taking the value that's for x and they're plugging it in for x in the equation. So you'll notice that 1 is plugged in there, 2 is plugged in there, 3 is plugged in there. Now, what they don't show us is what this true and false business is going on over here. Okay, so let's talk about the simplification of this right here. So I'm going to bring that over here, and I'm looking at 5 times 1 minus 1. 5 times 1 is 5, minus 1 is 4. And so what they're asking themselves is 4, which is the left side, equal to 9, which is the right side. 4 is not equal to 9, which is how they deduced false. It makes, when I plug in 1 for x, this equation becomes a false statement. Now, when I look at this statement, I now have 5 times 2 minus 1, which is 10 minus 1 is 9. So the left side of the equation is 9, the right side of the equation is 9, which is indeed a true statement. Finally, we look at the last equation. We've got 5 times 3 is 15. 15 minus 1 is 14. And 14 is not equal to 9. So this last statement is also false. All right, so let's talk about this in context of the entire equation again. So because the first and the last statements are false, what that means is, given the options 1, 2, and 3 to plug in for the equation, 2 is the only 2 is the only solution for this equation. So out of 1, 2, and 3, 2 is the only solution. For this example, they've switched up the notation just a little bit here. So you notice that instead of saying the domain x is blah, 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 they're saying that the variable in this equation is y, and they're saying y belongs to the set of 0, 1, 2, and 3. So here is how I might note that. Y is the variable. This symbol means belong to, and these curly brackets means set. Now, the book sets up this problem very similarly to the last problem. They take each value in the set of y, 0, 1, and 2, and put it in the column underneath the y. And then they transcribe the equation that we're testing here. So every time a y appears, plug in 0, plug in 1, plug in 2, or plug in 3. Then once I simplify the left side, I'm again going to be testing, is this value equivalent to that value? In this case, they are not equal. In this case, they are. Here, they are not. And here they are again. In case you're unsure exactly how each of these sides is simplified down in order to determine how false or true each one was, I indicated each, or should work for each of those steps here. So pause the video, check it against your work, and then you can return to the explanation. The last little bit of this example is how to read this explanation or the solution. What we found is that two numbers from the given set for y, which we're calling the domain, two numbers allow the equation to be true. And so this whole problem has two solutions, 1 and 3. So the solution set is going to be two numbers from the original set, 1 and 3. This is the domain, the options or the possibilities to try. This is the range, or the two numbers that actually make the problem true. Okay, the last little bit is this symbol here. It's read as therefore. So the solution, the entire solution reads, the solutions are 1 and 3. Therefore, the solution set is 1 and 3. All right, so this example has a little bit more going on. We still have a domain which is 6, 8, and 12. They're not telling us what the variable is. They're just saying domain. Domain means these are the options. This is what I want you to plug in for the variable once I figure out what the variable is. Okay? And instead of giving us an equation, they give us a sentence that we then need to translate into an equation. And they're asking us, what is the number? Okay, now, in the book, they don't actually translate that sentence into an equation. I'd like to do that, though, just to make things just a little bit more consistent and easier to see. All right, so I read the sentence, 5 more than twice a number is 29. And there are a few key words that come into play. I've got the number 5 going on, and then I've got this 29 hanging out. Okay, now what I need to do is figure out what goes in between them. Some key words that I notice are more than. More than, for some people, might indicate those symbols, but in the context of this sentence, it actually makes more sense for it to mean addition. So erase these symbols and instead focus on addition. So I have 5 more than something. Now, this twice means 2 times, and then they give us this a number. A number indicates that we don't know what the number is, so let's insert it with a variable. In this case, why don't we call it n, since it's a number? And then the last key word is is. Is indicates equal. All right, so we just translated the sentence 5 more than twice the number is 29 into 5 plus 2 times n equals 29. So now what you see I've done is I've taken the table and transposed it. I've made it, instead of number, I'm calling this column n. And then I've rewritten the sentence into an equation, and then I've labeled the true-false column. And now what I've shown you is this, I've shown the work for how I've simplified the left side of each of these expressions and then compared the simplified answer to the right side of the equation. So in this case, 17 compared to 29, 21 compared to 29, and 29 compared to 29. What I encourage you to do if you're getting a different answer or if you're confused is to pause the video, check the work, ask questions, and then return. Returning to our solution, we see that the only number from the domain that ended up making the equation or the sentence true is 12. Therefore, there's that symbol again, therefore, the number is 12.